going so fast? My heart's about to explode. What's happening?
Let me teach you what's happening. Let me teach you about the cardiovascular system.
The cardiovascular system is essential. It transports oxygen and nutrient-rich blood throughout the body. At its center, we have the heart, a powerful muscle with 4 chambers. We have 2 atria and 2 ventricles. The right side sends deoxygenated blood straight to the lungs, while the left side pumps oxygenated blood throughout the body. The heart has 4 valves. We have the tricuspid valve separating the right atrium and the right ventricle, the mitral valve separating the left atrium and the left ventricle, as well as the pulmonary valve separating the right ventricle and the pulmonary artery, and we have the aortic valve separating the left ventricle and the aorta.
Now that we know how the heart is structured, the important question on everyone's mind is exactly why this is important. We all perform a million different movements every day without thinking. Whether we're walking, resting, or even catching a ball, our heart plays a crucial role in ensuring we function at an acceptable standard. The key feature involved in the functioning of the heart is the valves. Valves are flaps of tissue that act like one-way doors for blood flow between the heart's chambers, controlling the direction and timing of blood flow. The valves open and shut in time with the pumping action of the heart's chambers and is controlled by a set of flaps called leaflets. The leaflets open to allow blood to flow out of a chamber and close to allow the chambers to refill with blood. So now that we know a healthy heart uses its valves to control blood flow, it's important to know that the opening and closing of the 4 valves is actually what forms our heartbeat. Once the deoxygenated blood enters the heart, the right atrium contracts, which opens the tricuspid valve to allow blood to flow into the right ventricle. The right ventricle then contracts, which closes the tricuspid valve, causing the lub sound of the heartbeat. This contraction triggers the opening of the pulmonary valve to allow blood to exit the heart towards the lungs via the pulmonary artery. Once the right ventricle relaxes, the pulmonary valve then closes, causing the dub sound of the heartbeat. Similarly, once oxygenated blood from the lungs enters the left atrium, it contracts, opening the mitral valve to allow blood to enter the left ventricle. This valve then closes once the left ventricle contracts, causing the lub sound of the heartbeat. To end off the cycle, the contraction of the left ventricle results in the opening of the aortic valve, enabling oxygen-rich blood to exit the heart towards the rest of the body via the aorta. This valve then closes after relaxation of the left ventricle, causing the dub sound of the heartbeat.
Now that we've gone over the 4 valves of the heart, let's go through a particularly special one. The mitral valve. It opens and closes at necessary times during the cardiac cycle to ensure that blood is moving in the right direction at the right time. Now, if you look over here, this diagram represents the cardiac cycle. So during diastole, the mitral valve is going to open. This means oxygenated blood is going to flow from the left atrium into the left ventricle, filling it and preparing it for contraction. As the heart moves into systole, the mitral valve closes to prevent backflow into the atrium, ensuring blood is just pushed inside. It stays closed during ventricular ejection as well, so blood moves efficiently into the aorta and out of the body. Then as the ventricle relaxes, pressure drops and the valve eventually reopens, restarting the cycle. Hence, the valves are crucial for enabling the efficient delivery of oxygen and nutrients through aiding the cardiac cycle. But did you know that the mitral valve itself is actually a coordinated system as well? If we look over here, it is categorized by its bicuspid nature. We have an anterior cusp over here and a posterior cusp over here. Both cusps are anchored by string-like fibers known as chordae tendineae, which are anchored to papillary muscle. So these papillary muscle are essential for stabilizing the cusps and ensuring that valves do not prolapse back into the atrium under the high pressure of the left ventricle. We additionally have the mitral annulus over here. I hope you learned something new. I'll hand you over to Muzan.
Has anyone ever dealt with a broken door? Picture the mitral valve as a door between the left atrium and the left ventricle. When it works properly, it closes tightly, allowing blood flow into the body. But let's picture the door failing to close properly. Now, this is known as mitral regurgitation, a valvular insufficiency, and it occurs during ventricular systole, where instead of the blood being ejected into the aorta, some is regurgitated into the left atrium. Now, there are 2 different types of mitral regurgitation. There's primary and secondary. Primary regurgitation occurs when there is damage to the valve itself. Bulging of valve leaflets into the left atrium causes the leaflets to become too stiff or stretchy to form a tight seal. Secondary regurgitation occurs when structures supporting the valve are affected, and certain heart diseases may shift the positioning of the valve and prevent it from closing fully. A leaking mitral valve causes blood to flow in 2 directions. During heart contraction, some blood flows from the left ventricle through the aortic valve to the rest of the body, as Shams mentioned, and some blood flows back into the left atrium. Now, this can cause diseases such as infective endocarditis, degeneration of valve leaflets, rupturing of chordae tendineae, or papillary muscle dysfunction. The physiological implications include reduced effective stroke volume, decrease in cardiac output, increased left atrial pressure and volume, which result in less forward blood flow reaching the organs and lungs. Now imagine I'm tapping my chest really fast. My body's response would be would react by increasing the heart rate and activate sympathetic responses. However, over extended periods, the atrial dilation would interfere with electrical conduction and consequently would lead to arrhythmias, particularly atrial fibrillation. So whether it's primary or secondary mitral valve regurgitation, the mitral valve can leak, making the heart's role more difficult to keep blood moving forward.
While failure of the mitral valve to close properly leads to regurgitation, another form of dysfunction is mitral stenosis. This occurs when a valve opening narrows due to thickened, stiff cusps, as you can see here, reducing blood flow from the left atrium to the left ventricle and limiting ventricular filling. Although different from regurgitation, both conditions reduce the efficiency of blood flow and lower cardiac output. As blood accumulates into the left atrium, pressure increases, causing dilation and backflow into the pulmonary circulation. This leads to fluid accumulation in the lungs and impaired gas exchange, reducing oxygen delivery. To compensate, the heart increases its workload, placing strain on the heart and potentially leading to heart failure.
So how do the consequences of mitral valve failure on cardiac function impact the body? Let's look at Tala over here. She used to be able to reach level 3 easily on the treadmill. But over time, she has realized that she is starting to experience fatigue and shortness of breath. Even when she decreases it to level 1, she feels lightheaded, experiences heart palpitations, and has noticed swelling in her feet. These are all symptoms of mitral valve failure.